This video is to discuss the idea of slope. You may be familiar with slope. You may remember it from Algebra 1. You may know how to use it to graph things, but we're just going to discuss the basic idea of slope. The first thing you want to remember about slope is that it's the ratio of the vertical change to horizontal change on a graph, or what's often referred to as rise over run. If you're thinking about a graph, as you go on a straight line has slope because as you rise, it's going to rise in a vertical change, or the change in x. And it's also going to move to the right or left, which is considered the change in y. This triangle means change. So, rise over run is a great way to refer to the slope of a line as it rises and runs at the same time. Now, more helpful defining slope is how to find the actual value of a slope. And we use the letter m to define slope. So we can write that up here so we don't forget. M refers to slope. And we're going to find the change in y, the rise, y2 minus y1, divided by the change in x, or x2 minus x1. And again, that's going to help us define rise, the changes in y, over run, the changes in x. So if you were given 2 points, the basic idea is we're going to take our y values on the top. So I'm going to take this 7, consider that to be y2, and subtract off this 3 being y1. On the bottom, because 7 was y2, I'm going to use 4 as x2. We have to relate both numbers from the same point need to come first, and the second 2 numbers have to come after that, so that we don't crisscross our numbers. 7 minus 3 is 4, and 4 minus 2 is 2, so the slope of the line between those 2 points would be considered 2. Go ahead and try that same idea with the 2 points given here. Now you may notice that my numbers are a little bit backwards from yours. I intentionally sort of flip-flopped my numbers. I used y2 and y1 from the first point. Remember that it doesn't matter which point is which, as long as if I start on the top with 15, I need to start on the bottom with the 2. So 15 minus negative 3 becomes 15 plus 3 is 18. 2 minus 5 is negative 3, and the overall slope comes out as a negative 6. One other thing we refer to with regard to slope is what's called steepness. And steepness doesn't matter if it's positive or negative. Steepness refers to which one of these slopes is larger. So the absolute value of 2 or the absolute value of negative 6, we're just trying to figure out which of those two comes up larger. And because 6 is greater than 2, therefore negative 6 comes from the steeper of the 2 lines. It's just which one has the larger slope. It doesn't matter if it's positive or negative. Remember that a positive slope rises from left to right. A negative slope, on the other hand, would fall. So that's a negative m, whereas this would be a positive m. Negative slopes fall from left to right. Another quick reminder for you is just that parallel lines have equal slopes. If you draw 2 lines that rise and run at the same rate, again, a ratio of vertical to horizontal, but if they rise and run at the same rate, they're going to be parallel. They'll never cross. And perpendicular lines have negative reciprocal slopes. We'll talk more about that in a little bit. Again, slope is really just a rate of change. So we can use it as a ratio, and therefore we can also use it in proportion. These are instructions for an old manual of how to put a ladder properly against a house so you don't fall backwards or slide forward. So what we want to know is, what is the ideal slope of the ladder? Well, if 3 feet from the wall and 12 feet high is the ideal slope, remember we're going to just say rise over run means that 4 is the ideal slope of a ladder. Now we can use that same 4, or 4 over 1, if that's the ideal, to help ourselves figure out if we want to go 20 feet up a wall, how far from the base should we put the base of the ladder? Well, the rise is 20 feet, We don't know the run, but it should be in relationship to 4 over 1. So if you do a little cross multiplying, 4 times x, 1 times 20, and if you divide by 4, we should place that ladder 5 feet from the base of the wall. And we can use that ratio, that perfect ratio of 4 over 1, or the ideal ratio of 4 over 1, to help us find other answers. We can use that same idea to help with this Mojave Desert question. Take a second to read through the question and see if you can't at least start off finding the average rate of change. Average rate of change just being another way to refer to slope. Right, one tricky thing to figure out is how to use the time in this question. Since they're using clock time and not just rate or lengths of time, we want to sort of redefine what we're thinking. I'm going to define 2 p.m. as time t equals 0, so that we can say, well, if I want to find that slope that's happening, we're going to drop from 100 degrees to 68 degrees, going from time t equals 0 to time t equals 15. And you will notice that we do end up with a negative number, as 100 minus 68 is 32, but 0 minus 15 is a negative 15. I've already got my negative on there, so I better erase one of those two. But that's going to be a negative 15. But there's the slope at which we are dropping, so therefore it makes sense that we're going to drop 32/15 degrees every hour. So there is our average rate. That's in degrees per hour. Now, how can we help use that? We'll use it to determine the temperature at 10 p.m. Well, assuming that we're talking about the 10 p.m. that's between 2 p.m. and 5 p.m. or 5 a.m., 10 p.m. would technically be t equals 8. So we can just say that if we're going to drop 32/15 degrees per hour, if we multiply that by 8 hours, well, hours, according to our labels, are on the bottom and top, so they'll cancel away. And we can quickly figure out how many degrees we're going to drop. And from there, we'll just take our temperature, our 100 degrees at 2 p.m., and we can add on whatever that drop is, and we will have our temperature at 10 p.m. So let's go ahead and pop our calculator out here. So 32/15 negative 32/15 times 8 hours, and then if we just add that on, and actually we better go ahead and find that in decimal here, negative 17.067 degrees, and then if we take that and add it on to our 100 degrees, add on 100, and we will find out that we're going to be about 82.933 degrees Fahrenheit. And there you go. Final thing I want to mention again is just mentioning parallel versus perpendicular lines. Again, I already talked a little bit about it, but if both lines have a slope of 3, then they're actually going to be parallel lines. They're both going to be rising 3 units at the same time that they run 1 unit. Or if we take a look at this one, as you run 1 unit, you rise 3 units. If they have the same slope, they're going to be parallel and never cross. Perpendicular lines, on the other hand, have negative reciprocal slopes. So again, these two lines come out perfectly perpendicular at a perfect 90-degree angle, because one has a slope of 3 and the other has a slope of negative 1/3. One great way to double check that is to be sure that if I know that that blue line has a slope of 3 and the red line has a slope of negative 1/3, if I multiply those two, they will always come out to negative 1. That tells you that they are negative reciprocals of one another. Again, just a reminder for you, we'll talk more about that when we get into more graphing. Hope that helps you with slope, and have a great day.